Hi, I'm Pat. All right, in this problem, they give us this function, g of t equals 4t squared minus 3t plus 5. Give you a function, and the directions tell us to evaluate each function or find each function value if possible. And so they're looking in this case for g of 2, g of negative 1, and then this g of t plus 2. And what we're practicing really is the concept of function notation. I'll try to stress that because that'll be the key for the setup for each one of these problems. And what I'm talking about is function notation, is they always give you the function to start, g of t. What that always means is 4 times whatever your argument is, but squared, minus 3 times whatever your argument is, and then plus 5. Okay? So each one of these problems, what you're doing is just taking that argument, like the first one I'll do, g of 2. My argument is 2, and I look to the function, and I write down everything that's kind of like locked in, for instance, the 4. That coefficient of 4 is always there. Then, whatever the argument is, that exponent of 2 is always there. And the only thing that's going to be different is instead of t, I'm putting in my specific value of t, which is 2 in this case. Okay? So the function notation is telling me to take this argument of 2 and put it in wherever I see a t. Okay? Now that's just the first term, so you got to keep going. In terms of what's locked in, the next thing is subtraction. It's always subtraction. It's always 3, and then it's times whatever the argument is, which in this case again is 2. And then plus 5. Just to finish the color coordination there, that t gets replaced with 2 because my argument is 2 for this problem. Okay? All right, start yourself off set for success by looking at the function that's given to you and just replacing the argument with whatever the specific thing is that they give you for this problem, in this case 2. Okay? All right, then I'll go ahead and simplify or evaluate, try to clean up as much as you can. So 2 squared is 4, and that's still being multiplied by the 4 that was the coefficient. Minus 3 times 2 is 6, plus 5. 16, take away 6, that goes down to 10, but then plus 5. Final answer of 15 there. Okay? All right, good. A good warm-up too, but keep that same thought process as you go through any one of these problems. Is now my argument is negative 1, so 4 times negative 1, but squared, minus 3 times negative 1, and then plus 5. Again, it's whatever the argument is, that's going every place that I see a t, whatever that independent variable is in my function. Okay? And then clean up. Negative 1 squared is just positive 1. Minus 3 times a minus 1 would give me a plus 3. And then plus 5. Let's see if I can fit it in here then. 4 plus 3 is 7, but then plus 5 looks like 12. Okay? All right, good. And still what I might call warm-up, because here's the third part of this problem. It's going to be the bigger challenge, although if you're following this thought process, now my argument is the entire t plus 2, whatever's inside those parentheses. Now take t plus 2 and substitute it into the original wherever there was a t. So this will equal the 4 coefficient, still there, that's locked. Parentheses, t plus 2, close parentheses, squared, because again, that's just me replacing the t plus 2 argument in for the variable of t, okay? T was squared, so t plus 2 is squared, all right? Let's keep going. Next is a minus 3 times whatever the argument is, in this case, t plus 2. Be careful, use parentheses there, even like I did with the minus 1. It was minus 3 times whatever the argument is. Same deal, minus 3 times. the entire expression of t plus 2. Okay, next, plus 5. Okay, good. I'll finish again with the color coordinating, but now it's cleanup. And the cleanup here is less computational than it is algebra, but that's okay. We can do that. And by algebra, I just mean like t plus 2 squared, you would FOIL that out. The 4 is still in front though, don't lose that. But if I FOIL that out, I'll get t squared plus 4t plus 4. And again, that 4 is still out in front, multiplying. Okay, minus 3 times these parentheses. Let's do a distributive property. So minus 3t minus 6. And then plus 5 is still tagging along. And I'm still going to try to continue to clean up, do a little bit more algebra. Like here's another distributive property. And as I do this one though, let me see if I can combine some like terms as I go. 4 times t squared, and there are no other t squareds, so nothing to combine. 4 times 4t is 16t, but there's a minus 3t. So how about combining and getting plus 13t? 4 times 4 is 16, but then take away 6 goes down to 10, but then plus 5 looks like plus 15. Okay? All right. Try some of these on your own, of course, but this is a pretty important concept, being able to handle function notation no matter what the function is and no matter what the argument is that's thrown at you. All right? Okay, try some on your own.